Hi, I'm Michael, the founder of Steelo, the leader in structural steel. I'd like to show you how we work to support your build.
Thank you very much, and thanks for joining me. Let's crack on, because we're slightly late than we were meant to be starting. Quickly about myself, as introduced, I'm Michael Krajewski. I'm an aeronautical engineer by education, but then in 2007 I came across the structural steel world, and I literally fell in love into it because I saw that there's so much that could be improved on. And till this day I am straight on in the innovation side of things. And the whole company was built because I wanted to revolutionize the industry. That was the purpose, and it is still alive to this day. We have a strict set of rules, our values that we follow, and all of this together allows us to be reliable. And that's why I love the word reliability and the whole thing about being reliable. We're quite lucky when it comes to media. The media reaches out to us because, I don't know, they like us. So we've been on various programs. To me, time is everything. We all know that time is the most precious asset. That's something you can't negotiate. But to me, it's more than that. We all know that we won't be as young as we were yesterday, and being able to live in that space, in the space of time, is crucial in everything we do. Every construction site is made because there's an idea of a return on investment. The formula is very simple. It's obviously the profits related to the amount of money we put in, but we all know that it relates to time. If we made a 10% profit over 10 years, that's obviously no good because it's only 1% in a year. So that's why it's also related to time. So in other words, if we have a project that's going to cost us £1 million or dollars, whatever the currency, it will cost us $19,000 per week. And this is the cost of being unreliable. So we, as steel suppliers, we know how important it is to deliver on time. With steelwork, the people who are involved in steelwork know that it holds back a lot of work. To erect this kind of frame takes around 2 days, maybe 3, but without this frame, there are many trades that cannot commence their work. So the bricklayers, the dryliners, all the timber guys. So there's no reason why a steel frame can be late on site. And to us, that's a top priority. Being a reliable supplier is the most important thing that we can do as a company. The beauty about reliability is that it's not just a single word. It actually comprises of two things. One is time, which is quite obvious because I already introduced you to it. Does anyone like to guess what is the second component of reliability apart from delivering on time? Never be late. Any other? It is the quality. Well done. Yeah. There's no point in delivering something that doesn't meet the specs. On the other hand, there's no point in delivering something that meets the specs 1 month later. So that's why it's the combination of the two that gives reliability. And the most fascinating thing about reliability is that it's always in the past. If we were a reliable company a year ago, we can't rely on that fact in the future. And we have to prove that we are a reliable company every single day. And the same refers to us as people. If we used to be a person that comes on time a year ago, that doesn't mean we will be on time now when we agree a meeting with someone. So reliability is something that we are tested against every single second of our lives. So we know the theory behind reliability. The question is how to make it happen. But before we delve into answering that question, we have to start with the bitter facts of the demographics ahead of us. The construction industry, we're part of it. We are going to be the victims of what's happening. The amount of skilled workforce is declining. and that is a fact. The younger generation, referred to as millennials, does not want to get involved in, let's call it, the dirty work. And we can't blame them, because looking at we don't get involved in the dirty work as well. So it's a trend, a global trend. So we just can't blame our lazy young generation. It is a matter of fact that we have to deal with. The obvious consequence of the numbers declining is the fact that the cost of labor will go up. And this opens up a huge opportunity for anyone who wants to implement innovation. And that is why I always think of innovation as being a requirement for reliability. So it's not that we just want to innovate for innovation's sake, because we could innovate anything. We could introduce drones easily and so on. But if that doesn't allow us to become more reliable, then there's no point in doing so. There's a company called Fortman. They're based in the Netherlands. They are working on this kind of machine, which automates the assembly process of a steel beam. In our world, it doesn't quite work out, because the size of the beams that we fabricate are a bit smaller, and regardless of the size of the beam, the handling time is roughly the same. So obviously the higher, the greater the weight, the better the margins. We decided to go a step further. We didn't want to copy what someone else was doing. So we started researching the industry, and we found out that there's a university, and it was Cranfield University, that was working on 3D printing of steel. Over the last few months, we've sponsored a master's degree around it, and we've now teamed up with all the other companies, so with Warwick University, Lloyd's registered to have it approved, Faster & Partners, the architectural company, and also Global Robots, the supplier of the robots. This is an Innovate UK project, and the whole idea is to print steel for structural purposes. And this is what it looks like in the laboratory. So in other words, instead of welding a plate to the end of the beam, we have the robot printing the plate. So this is a close-up view, and I have a sample with me. This has been used for testing, so that's why the bottom flange is missing. But this is what it looks like. It's a bit rough, and that's why we had to get in touch with University of Warwick, because they'll be doing some structural analysis on the impact of the smoothness of the surface. But then also with Foster's being on the team, they are pushing towards creating some very interesting nodes and beams that are impossible to fabricate in the old way. So this will be a game changer. It still might be a few years, but this is quite exciting of how it can change the steel industry. Once we master the art of printing plates, we will then get computers to modify steel structures in order to optimize them. So like Formula One's a great example. 30 years ago, we had a front wing that was literally straight. It did a job. It created some lift or downward force. Whereas now, because computers were taken on board, the shapes that a computer can produce are just outstanding. A human would be never able to produce that kind of shape. And the same as with structural steel. There's no need to have all these lumps of steel. They can be optimized in a big way. And maybe in the future we won't have any fabrication shops. It might be that the robot will be on site printing the superstructure as we go, obviously creating shapes that are impossible to do by humans. So it might be that the structure in the future will be so optimized that it will be literally bearing the load that it was designed for without any waste of material. The downside of this kind of structure, the mesh idea, is obviously fire resistance, because once this catches fire, it will go like crazy. But that's one of the things that needs to be addressed, and we need to find a solution to it. Luckily, we did have artificial intelligence just before my presentation. We did experiment with AI a few years ago before it became the sexy word and the hype thing to do. The idea was to automate the quoting process, because at the beginning of every project we get sent structural drawings, and then our estimators need to browse through and find everything related to steel. So we've programmed a bot that run through all the drawings and highlighted or anything to do with steel, and this is a printout of the software. We surprisingly got caught out on a thing that sounds very funny, but the size of the file just killed the project, because one page weighed about 12 meg, 10-page document was 120 meg, and we very quickly got into the gigs. And 4 years ago, transferring 4 gig into gigs just for one project was just unfeasible. So we did put it on hold, but we are now looking into getting back to the idea, although because we've put it on hold, we came up with a few other ideas. And one of the ideas was to actually enable end customers to place orders from their phones. So basically, we bypass the whole office, and thanks to the system, we get an order straight to production. So the problem with small builders is that because of the extended lead times for fabricated steel, they are forced to order the steel all in one go. The problem with that is that in many cases, it is impossible to measure up a building, to measure everything and order the steel in one go so that it fits on site. So we've decided to split every project into small components and enable the builder to order in phases. So we've created a platform called Mr. Beam, and you can go online and order a beam or a structure. But please don't confuse it with this fellow. It sounds familiar, but it's Mr. Beam, not Mr. Bean. This is what it looks like, and if you place an order by midday, we are able to deliver to site the following day. And this is what I'm talking about, reliability. We've made our plant as reliable as possible, and this is one of the components to make it happen. Another thing that we've introduced is the theory of constraints. Has anyone come across the theory of constraints? No. It is a wonderful piece of work. It is the author is Yahoo Goldratt. He is, well, he's dead now, but he was in physics, academic, and he looked at the project world, and he just said, well, something has gone seriously wrong in the project world. And he gave a solution from the academic world to projects. So the whole idea is that in the world that we live in, any project or any manufacturing plant, there are plenty of variables. So any machine can break down at any time. Someone can just decide not to come to work, and so on. And that is impossible to manage, especially in an environment where every order is bespoke. And that's the environment that we're in. Every single beam, every single project is different. And this is the reason why lean manufacturing, the Toyota concept, does not work at our place. The reason behind that is that if you lean the whole process, that means that a bottleneck or Murphy can pop up anywhere. So suddenly you're firefighting with so many variables, and it's impossible to run a reliable plant. So his idea is to find a global minimum of the whole project, of the whole machine, or if it's a manufacturing plant, then the whole plant. And this is based on the Lagrange equations. If anyone's from the mathematician world, then they will know what it's all about, but it's about finding the global minimum. And in other words, you find a bottleneck within your system, and you can determine any bottleneck. It can be a process, it can be a machine, and then you build the whole project or production plant so that the other processes have built-in spare capacity. And by doing so, you know that if a process with spare capacity breaks down, one machine out of two breaks down, you still know that you'll be able to feed the bottleneck because you've got built-in spare capacity. So in this scenario, the only thing you're worried about is to regulate the size of the bottleneck. Bearing in mind that there will be no bottlenecks behind the process, and there's enough of material in the buffer before the process. So it's a very simple idea, but it just makes everything very, very easy. ERP systems don't work in our environment because ERP systems are great at defining every single second of every resource. The problem is that if one resource breaks down or doesn't turn up, then the whole planning process has to be done all over again. And then it turns out that the most optimum way of fabricating is totally different. So then people are forced to move work in process from one unit to the other. Whereas here, everything is simplified. You only focus on the bottleneck, and that's how you control the global throughput of the system. This is, for manufacturing, it's called the drum buffer rope method. So the drum is the bottleneck. You have built-in capacity in all other resources. You make sure you have enough material in the buffer so that if anything before the bottleneck breaks down, you have enough time to repair it so that it doesn't cause any issues at the bottleneck. And then the rope, which is also from Toyota manufacturing systems, is that you control the release of work. So in other words, if there's in our world, if we have a cutting machine that's able to cut much faster than we are able to fabricate the steel, then there's no point in the person cutting just delivering a pile of steel, because it will clog the system. So flow is the most important thing in production. It has to be smooth and it has to be consistent. Now, in our world, what would you choose to be our bottleneck or our drum? Which process? What is that, sorry? What did you say? No, you didn't. Remembering that a bottleneck, if we lose time on the bottleneck, it's time lost forever. We can't make it up. We can't regain the time. In our world, we used to have it as our welding. So each bay was part of our bottleneck, but we quickly realized that there's another bottleneck. And the bottleneck, or our drum, is... Once again, sorry? The weather. Yeah, could be. But in our situation, it was the logistics. We can only deliver between 8 and 5. If we're late, we can't deliver at 8 p.m. because it is basically too late. And if we've missed a slot today, we just can't make it up. So that's why our constraint is transport. Now, you might ask, well, why don't you add 10 more trucks? But that's the whole idea. You keep the bottleneck or the drum located at a single process. And because of that, it's very easy to control the whole system, in our case, our company. And we've built our own IT system around our bottleneck. And this is our delivery module. It is quite a fresh one because I've printed a screen from 11:05 in the morning. And as you can see, we have our trucks listed, and every tab is a project. And the grey project means that they've been delivered. Green one means that they still need to be delivered. And this is our drum. This allows every other process to work in line with our delivery schedule. So even if we get an order that must be delivered next week, we won't commence fabrication until the drum will inform the person releasing the material that we need to start fabricating. So this is choking the system so that the flow is much better. So because we treat time as something very serious, we have our brand promise guarantee, and if someone picks a 2-hour slot and we're late, we refund £100 to that customer. So that's how serious we take being on time. If you would like to find out more about the theory of constraints, I really recommend these 2 books. One is The Goal. That's more to do with manufacturing. And the second one is Critical Chain, which is to do with project management. And they are very easy books to read because they're business novels. So you'll have plenty of love and affairs and problems in life and so on. And between the novel, you'll just figure out what the whole theory is about. We are constantly recruiting as a fast-growing company, so if anyone would know anyone or would like to join us, then please apply. We've got a careers section on our website. We are branded as the startup in the steel world because we are very fresh, dynamic, and we just like introducing various ideas. We're also looking at consolidations. The industry will benefit from companies getting together with reliability in mind. So whenever we're looking at other acquisitions, we're looking at the fact of improving the reliability of that company. If you'd like to connect with us, then please join us on these social media platforms. We also run a Steelo Academy, which is a 2-3 hour seminar which is aimed at structural engineers, architects and main contractors. We basically invite them to our offices and I don't want to use the word teach, but we tell them what is the best way of designing steelwork so that it fits on site in a safe way. Because what we come across quite often is a design made by a structural engineer that is impossible to assemble on site because the bolts are in an accessible area and so on. So we give feedback of what is the easiest way to design the steelwork so that it's easy to manufacture and then also very easy to install. And the safely is very important. We don't want people to get injured on site because they had to fiddle with a steelwork that was designed in a not most optimal way. So please go on our website and you can find out more about it there. We are based down over there, downstairs, so please visit us at stand G16. There's another steel company here, the A13. We have the owners there. They are our friends based in east of London. They are also a legitimate, reliable company, and we like working with these kind of companies. If there were more companies like that, the whole world would be a much nicer place. Thank you very much.